And we've got a nice big sensing circuit question to finish up today. Where potential dividers really come into their own is when one of your two components or one of your two resistors is a variable resistor of some sort. So it could just be a variable resistor where you change the dial, or here we've got an LDR, its resistance changes when light shines on it, or you could have a thermistor, its resistance changing when the temperature changes. Now remember that this voltage reading here is going to be, this resistance out of the total resistance times by the total available potential difference, and that's going to be the same as the EMF there. So if R changes, if the resistance of this changes, then the voltmeter reading is going to change as well, and the voltage available to a little sub-circuit that you put there would also change. And this allows you to have things happen when the light level changes or when the temperature changes. So to finish up today, have a go at this question. That bit at the bottom doesn't quite fit, it's for 4 marks there. Okay, so you could use the potential divider formula if you wanted. We're told that the voltmeter reading is 5.1. So if you put 5.1 there, you can work out what R is. To be honest though, I'd probably do it the other way. I'd probably say if this is 5.1 volts, then that means the voltage across the resistor is 0.9 volts. And then I'd go, okay, so the current is V over R, and get the current in the circuit, and then use the Ohm's law formula again to get the resistance of the LDR. What that means, of course, is that we've already done the next part of the question. Obviously, don't forget to copy that into the space. Now for the last part of the question, we're told not to refer to the potential divider equation. So what happens when the circuit is moved into the sunlight? Well, this is the graph for an LDR. So if we move the circuit into the sunlight, the light intensity goes up. So the first thing I'm going to say is that the resistance of the LDR comes down for a mark. Now what happens? Well, if R comes down, that means the total resistance of the circuit has gone down, and so the current's going to go up. That's the second mark there. And if the resistance has gone down, then that means I'm also getting a smaller share of the PD, the available PD, and so the voltmeter reading will also go down. Where exactly the 4th mark is, I'm not sure there. Well done if you got all the way through that one.